Hello guys, in this video we are going to discuss the solution of the problem kth missing positive number in a sorted array. So let us look at the problem statement. The problem statement says given a sorted array of distinct positive integers ARR, we need to find the kth positive number that is missing from ARR. So for instance, if this is the array which is given to us, we need to find the fifth missing number, and the fifth missing number, as you can see, is 9, because of which we are returning 9 over here. So that's the problem statement, folks. Now let us discuss the solution of this problem. So the general idea is to use binary search to find the first number which is greater than I plus k. So what we are doing over here is we are applying binary search to find the first number which is greater than I plus k. Then in order to find the missing number, all we have to do is we just need to return I plus k. So that's the brief idea in order to solve this problem, folks. Now let us take these steps in detail. So let us take an array such that none of the elements are missing. So as you can see, it contains 5 elements and none of the elements are missing over here. And these are the indexes of these elements. Now if you compute the difference between the indexes and the element, then the difference will be 1. So 1 minus 0 is 1, 2 minus 1 is 1, and so on for all the elements. Now let us say from this array, one of the element is missing. So let us say in this case, this element is missing. Now, if this element is missing, then the array will look something like this. Now again, let us compute the difference between the index of the element and the element itself. So over here, the difference is 1. Over here, the difference is 1. Over here, the difference is 1. And over here the difference is 2. Now let us take an example where 2 elements of the array is missing. So let us say these are the 2 elements of the array which are missing. In such case, the array will look something like this. And again, let us compute the difference between the element of the array and the index of the array. So over here the difference is 1, over here the difference is 1, and over here the difference is 2. Now if only one element is missing from the array, then in such case there will exist an element in the array whose difference is 2. Similarly, if 2 elements of the array are missing, then there exists an element such that the difference between the element of the array and the index will be 3. And folks, over here k was equals to 1 since one element was missing. And over here k is equals to 2 since 2 elements were missing. And to generalize this, what we can say that if from an array k elements are missing, then there exists an element ARR I minus I is greater than k. So for instance, in this case, when I is equals to 2, then ARR 2 minus 2 is greater than 2. And if we compute this further, we can say that 5 minus 2 is greater than 2 and 3 is greater than 2. Similarly, in this case, if we compute this, ARR 2 minus 2 is greater than 1. So let us compute this. 5 minus 3 is greater than 1. So 2 is greater than 1. And thus we came to this conclusion that if k elements are missing from an array, then there will exist one element such that ARR I minus I is greater than k. And we can rewrite this equation as ARR I is greater than I plus k. And that is exactly what we are computing it over here. So we want to find the first number which is greater than I plus k. Once we have found out that number, all we have to do is, in order to find the missing number, we just have to return I plus k. So for instance, in the same example, this is the first number which is satisfying our condition. So what will be our answer? Well, our answer will be equals to I plus k. So in this case, I is equals to 2 and k equals to 1. So 2 plus 1, which is equals to 3. So in this example, as we can see, this is the first number where the condition gets satisfied. And in order to get to our answer, all we have to do is we just have to return I plus k. Over here, I is equals to 3 and k is equals to 1. So our answer will be 4. And if you see over here, 4 is the first number which is missing from this series. Similarly, in this case, this is the number where the condition gets satisfied. And in order to get to our answer, all we have to do is we just have to return I plus k. So 2 plus 2, which is equals to 4. And as we can see, 4 is the second number which is missing from this equation. So that's the idea behind solving this problem, folks. Now let us take an example to understand this. So let us say the array which is given to us is this, and in this array we need to find the fifth missing element. Now what we are going to do is we are going to apply binary search to find the first element such that ARRI is greater than I plus k. For that, since the array is already sorted, we are going to apply binary search. In order to apply binary search, low will be equals to 0, which is the first index of the array, and high will be equals to len of array minus 1. So in this case, this will be equals to 4. Now we are going to compute mid, and mid will be given by 0 plus 4 minus 0 divided by 2. So in this case, mid will be equals to 2. Now we are going to check if ARR mid is greater than mid plus k. Essentially, ARRI is greater than mid plus k or not. In this case, ARR2 is 4. Is 4 greater than mid plus k? So 2 plus 5. Since 4 is not greater than 7, because of which we need to search the element in the right part of the array. So for that reason, we are going to set low is equals to mid plus 1. So over here, now low is equals to mid plus 1. So low becomes equals to 3 and high is equals to 4. Let's compute mid. Mid will be equals to 3 in this case. Again, let us check if ARR mid is greater than mid plus k. So ARR mid is 7 in this case. Is 7 greater than mid plus k? As we can see, 7 is not greater than 8, because of which we are going to again update our low. So let us update our low. So low will be equals to 4 and high will be equals to 4. In such case, mid will be equals to 4, and let us check if ARR mid, which is equals to 11, is greater than 4 plus 5. Since 11 is greater than 9, because of which we are going to set our answer to mid plus k. So mid plus k. So answer will be equals to mid is 4 plus k, which is equals to 5. So our answer will be set to 9. And then our objective is to find the first missing element, because of which we are going to update our high to mid minus 1. So in the next iteration, low will be equals to 4 and high will be set to mid minus 1. So this becomes equals to 3. And since low is not less than or equals to high, because of which we are going to break from our binary search logic and we are going to return our answer. And answer in our case is 9. And this is what we are going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the kth missing number, and an array is given to us and value of k is given to us. So for this, let us set low is equals to 0, high is equals to length of array minus 1, and let us set answer is equals to len of array plus k. Folks, this is for the case where let us say none of the elements are missing. In such case, the kth missing number will be given by length of array plus k. Now let us apply our binary search. While low is less than or equals to high, then let us compute mid. Mid will be equals to low plus high minus low divided by 2. And then let us check if ARR mid is greater than mid plus k. If this is the case, then answer is equals to mid plus k. And since we have to search the first element such that ARR mid is greater than mid plus k, because of which we are going to set our high equals to mid minus 1. Otherwise, we are going to set low is equals to mid plus 1. And towards the end, we just have to return our answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here, low equals to 0, high is equals to length of array minus 1, and answer is equals to length of array plus k. Then we are applying binary search in order to find the first element such that ARR mid is greater than mid plus k. If that is the case, then answer is equals to mid plus k and high is equals to mid minus 1. Otherwise, low equals to mid plus 1. towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Low equals to 0, high is equals to length of array minus 1, answer equals to length of array plus k. Then we are applying binary search in order to find the first element such that ARR mid is greater than mid plus k. In such case, answer is equals to mid plus k, and towards the end we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.